as we finish up this module, I just have a few more things to practice. I'd like us to practice simplifying these exponent problems. Again, we're going to work piece by piece through these problems. They may seem overwhelming at first, but when you start breaking them apart, they're really quite manageable. So this would be 6 to the negative 2 times x to the negative 4 over x to the 2. And then I'm going to have a y to the 10th over y to the negative 6th. So I just gave myself a little bit more room to work with this. Make sure you give yourself plenty of room to work. So this will become 6 to the negative 2 is 1 over 6 to the second. Not 1 over 62. There we go. X to the 4th over x to the second, x to the negative 4th. It's going to turn into x to the negative 4 minus 2. And then the y to the 10th minus y to the negative 6th. So what I end up with, come back down over here. Actually, I should be that to begin with. Let me see if I can grab all of these pieces together. Just move them down here. This might be a better way to work. With these problems on the whiteboard, it's hard to figure out the best way to present them. So, ultimately what I'm left with is 1 over 36 times x, negative 4 minus 2 is negative 6. And then I've got a y to the 10 minus negative 6, that's a y to the 16. And remember, this x to the negative 6 wants to be down in the denominator. So, finally, I have a y to the 16th over 36x to the 6th. Some of your problems may take this much room to work out. Some of them may go by a lot faster. Excuse me. It all depends on how you work. So with a problem like this, I could approach it, excuse me, I could approach it many different ways. I could deal with the negative exponent first. I could distribute my power through first. It doesn't really matter. I'm going to distribute my power through. So the negative 1 is going to multiply that negative 2. I've got a 6 to the 2 times negative 1, which gives me a 6 to the negative 2, which is a 1 over 6 squared, which is a 1 over 36. And that 1 over 36 is my final answer. With this x to the negative 5 to the negative 7, I like to distribute my exponents before I do anything else. It helps me get rid of my negative signs. It also gets rid of the parentheses. X to the negative 5 times negative 7, and the negative times the negative is a positive. This just gives me an x to the 35, and look how few steps that took me to evaluate. This next one might not take quite so few steps, but it's alright. Whole key is to take it one piece at a time. And this negative 2 wants to distribute to everything. And as it distributes to everything, keep in mind that that 7 and that x both have 1 exponents right now. So this turns into 7 to the negative 2 times x to the negative 2 times y to the negative 2 times negative 2. This 7 wants to move down to the denominator, as does this x. And this y with a y to the positive fourth on top. So I wind up with y to the fourth over, now 7 squared I can evaluate, that's 49x squared. And that's my final answer. If I move down a little bit, the nice thing about this software is I can just move these pieces wherever I want them. But I think I almost lost one of them here. You come back. Come back. There you go. I do want to make sure I have plenty of room to work. So I'm not afraid to just shove something off the side if I need to give myself some more space. This 6 is going to distribute to all 3 exponents. Now as I do that, it makes it really hard to read because of the pen. But I can write that as a to the negative 4 times 6, and b to the 3 times 6, and c to the negative 2 times 6. And I have an a to the negative 24, a b to the 18, a c to the negative 12. The a and the c both have negative exponents. I would like to move down to the denominator. So b stays up in the numerator with his exponent of 18. And I have an a to the 24 and a c with the 12 down in the denominator. I can guess that this problem is going to take up quite a bit of space, so I'm pleased with the fact that I have migrated these other problems down here. I'm just going to stack them on top of each other so I have plenty of room to work. This may feel very, very overwhelming at the beginning, but as soon as we break it into smaller pieces, it will become much more reasonable to deal with. So I'm going to distribute my outer exponents to everything on the inside, but I am going to mark in the 1 exponents where they are supposed to be, so that I remember to multiply. So when I multiply, I have a 4 to the 1 times 3, an x to the 3 times 3. What happened to that 3? To the 3 times 3, over a 3 to the 1 times 3, and a y to the negative 1 times 3. And that is going to be multiplied by another fraction. In here, I have a y to the negative 2 times negative 1 over a 3 times 1 to the negative 1, and an x to negative 1 times negative 1. Now again, there may be a shorter way of doing this. I'm just doing it the same way to be consistent. So I wind up with a 4 to the 3rd, an x to the 9th, a 3 to the 3rd, and a y to the negative 3rd. That's going to be multiplied by a y to the positive 2nd over a 3 to the negative 1, that was a 1 times a negative 1, and an x to the 1st. Now that I have dealt with the parentheses and the power raised to a power, now I can start grouping like things together. So my 4 to the 3rd isn't going to group with anyone else. So he's just going to stay a 4 to the 3rd. Put him in parentheses because he's not going to talk to anyone else. But this 3 and this 3 will talk to each other. So I have a 1 over a 3 to the 3 plus negative 1. 3 plus negative 1. Because I'm adding them together, they're in the same part of the fraction. And then my x's, I have an x to the 9th over an x to the 1st. And my y's, I have a y to the 2nd over a y to the negative 3rd. One last step, and I believe that I should be able to have this simplified. So I wind up with a 4 to the third times a 1 over 3 to the 3 plus a negative 1 is 3 squared. And then I have an x to the 9 minus 1 and a y to the 2 minus negative 3. So 4 to the third, 4 times 4 is 16, times 4 is 64. I've got an x to the 8th, that's that 9 minus 1, and a y to the 5th, 2 minus negative 3, all over 9. And that is how that one simplifies. You again may have seen a shortcut with that one, and that's perfectly okay as long as you're showing me enough work. If you're wondering about whether or not you're showing me enough work, just ask me. I would be glad to give you feedback on something like that. Alright, we've got 3 more to practice, and then we'll talk about how we know when something's completely simplified, and that will be it for this module. The strategy I'd like to employ with this 2 to the negative 1 over y, all to the negative third, I'm still going to distribute my exponent through. So I'm going to have 2 to the negative 1 times negative 3 over y to the 1 times negative 3. And so that's going to give me a 2 to the positive 3 over y to the negative 3, which results in a 2 cubed I can do. 2 cubed is 8, y to the third. So we'll section off that blue one. Scroll down just a little bit more. I feel like I haven't used red in a while. So again, I'm going to distribute the power through, making certain that I'm marking my exponents of 1. So I have 4 to the 1 times negative 2, a to the 3 times negative 2, b to the 2 times negative 2, all over b to the negative 6 times negative 2, and c to the 1 times negative 2. This gives me a 4 to the negative 2, an a to the negative 6, and a b to the negative 4, all over b to the 12th, and c to the negative 2. Now that I have distributed my power to all of my powers, I'm going to start simplifying the expression that I have here. I can tell I'm not done because I've got negative exponents, and my b appears more than once. So this is going to give me, I have a 1 over 4 squared, take care of that 4. This a to the negative 6 doesn't like where it is, so 1 over a to the 6th. And my c to the negative 2 isn't happy either, so I'm going to have a c to the 2 on top over 1. So those aren't communicating with any other variable, I'm just reconciling their negative exponents. But I do want to talk about this b to the negative 4 minus 12, because that's going to give me a b to the negative 16, excuse me. So when all is said and done, I have a c squared on top, a 16, that was my 4 squared, an a to the 6th, and a b to the 16th. That is the final answer for that one. We only have one left, and I believe I have enough room. Let's see. Now, I know I have been dealing with this negative exponent and bringing him inside first, but I don't have to. So what I might do instead is I might say to myself, okay, right now I have a y to the negative 7 minus negative, I can write what I'm trying to, minus negative 10, all to the negative 3rd power. So y to the negative 7 minus negative 10 gives me a y to the third, all to the negative third power because of this here. And so then I can say this is y to the 3 times negative 3, which is, I'm going to work sideways. Move him over here. And then he will come down here, so that's my next train of thought. Y to the 3 times negative 3, which is y to the negative 9, which is 1 over y to the 9th. I could have done this, again, multiple ways. There is no single right way to do this problem. There are many right ways. There are many wrong ways. So just be careful as you're going through that you're dealing with each exponent as you need to. So how do you know when something is finished? I have a nice little list here of ways to double check to see if you have your expression completely simplified. One of the most important rules is that there are no more negative exponents, so any negative exponent needs to change where it was in the denominator. In the fraction. So if I had 1 over x to the negative 3, this x cubed would be on top. If I have numbers with common factors, they need to be simplified. Negative signs will also be simplified. Numbers raised to powers are evaluated, but only if reasonable. If you could do it in your head, do it. If not, leave it as a number to an exponent, that's alright. 0 should never be seen as an exponent in a simplified answer. If you have a 0 exponent, you could have turned that into a 1 very easily. Variables, these two go together. If variables appear more than once, you haven't completely simplified. I have a y over a y here. I need to take care of that. And this one, I have an x times an x. I have to take care of that. So make sure that if your variables or your factors are occurring more than one time, they need to be combined. And then lastly, no more parentheses. If you see parentheses, it's not simplified. You can still do something with it. So those are some nice guidelines for how something can be simplified. So with that, that brings us to the end of the new lectures for Module 1. At this point, you need to be working through your reviews and your homework sections, and come prepared to ask questions.